throw you all some tricks like that. And if you don't ask, you lose. Okay. So that is our free body diagram. Okay. So I'm going to start from a new page. Okay, because I'm going to write more stuff over here. So with respect to the free body diagram, so the net force, okay, the net force to accelerate the mass, and we know this is equal to MA, okay, and we know that MA is equal to M dV by dt, and we know that because it's y, this is equal to M d squared y over dt squared. Okay. Then we have the net force to accelerate, or net force not to accelerate, due to the spring and damper. This is equal to minus cy dot minus by ky. Okay. Why is minus? Because if you look at this, y positive is coming down. Anything that's coming down is positive. Anything that's going up is what? Is negative. Okay. So therefore, m d squared y over dt squared is equal to minus c dy by dt minus by ky. Okay, so finally, for unforced dam system, you have m d squared y over dt squared plus by c dy by dt plus by ky, the whole thing will be equal to 0. So this is what we call, so for this expression over here, it is a dam. Why is dam? Because we have a what? We have a C. Unforced, because this is equal to what? 0. Mechanical system. Okay. Okay. Now this is the fun part. You know, my research, and unfortunately a lot of things I approach life is this. If the physics and the math don't work out, I get really pissed off. I repeat again. You know that I felt like when I did it. Okay. Okay. I did mention in class yesterday that 4 hours. I know your page for what? 3 hours of lecture, 1 hour of tutorial. You have to know. I don't dare to lecture all the way. Okay. Yes. or y dot is dy over dt. Thousand apologies. I do apologize, okay? So as I say, in my approach, in my research, what you sometimes reply is the physics and the math have to work. Yes. Yes. Okay. Because we start analyzing after the equivalence has been achieved due to the math. It will still affect, but we are more focused on the acceleration that we are going to introduce into the system, not due to the gravity. Okay, we want to see, okay, we have gravity, but I want to accelerate how much acceleration I can induce without the help of gravity for each case. Later on, okay, then we improve gravity by case. Okay, let's get just purely, I want to accelerate this much. Okay, not considering the help of gravity. Okay, now the gravity part already extend, it's already absorbed by the what? Spring and the damper. Okay, my explanation is not very good yet. Watch this. If now I have a system, why am I writing on the board? Okay, let's recap. If now I have a system, this is my spring. Oi. Yeah. This is my spring, and this is my damper. No. No. This is my damper. Okay. Right? There's nothing. There's no mess. Can I answer his question? Okay. Can I answer his question? Okay. Right? Yes, nothing. We have not introduced the mesh. When you put the mesh, what will happen to the spring and the damper? It will extend. So now you have to see. So now the spring got longer. I don't draw bigger. Wait, you say, Eugene, you just change the freaking cross-sectional area. So the damper is still, the damper has been extended. With the what? Due to the what? The mesh. Then after that, then after that, then we analyze. So this has achieved what? Equilibrium. Because the spring extend and the damper move requires what? Energy. Required force. So when we start analyzing this, is the add-on, yes or no? Right? So now, I need to apologize to you later on, okay? Now, then we start the, you get it? Okay, I need to apologize to you. I tell you what, I'm behaving like how my old prof did me. When I explain, it goes louder by stages. Okay, it means the louder means you understand. Yes. What is that other part of the subject? That's the thing. Yeah. The spring is on its own. So this is spring. So this is Ky, and this is the damper, or C dy by dt. Okay? Right. So as I was saying, okay, the math and the physics have to meet. If it does not meet, I'm a miserable bastard. Really, and my PhD student gave up on me. Eugene, not always the math and the physics have to, it has to. Okay, that's why how many of you are dating mathematicians? Those doing math degrees? Miserable bastard. Okay, I've been through one before. Okay, if the math don't work out, it's like okay. That's that. But engineers, we tolerate more. Yes or no? We have what tolerance? Yes or no? Right? Yeah. So it's weird. Okay, but good weird. Okay. Right. So now we have a system over here. Okay. So I will tell you how this is derived. So we mathematically based on how we inject drugs into our body, we derive this expression where m is multiplied d squared y over dt squared plus by c dy by dt plus by ky. After that, we put the entire system together and we observe how the system behaves. I repeat again. We observe how the system behaves again. What's the problem with mechanical engineering? Okay. What's the problem with retard? What's the problem with you and me? We rely too much on the math and on the physics, right? If I were to put a chemical, if I were to put two engineers to make beer, who will make quicker? A chemical engineer, a mechanical engineer to make a beer, who will make the beer quicker? Any idea? Hey? Chemical engineers will make it quicker. You're right. Not mechanical. We will drink quicker than them. They will make quicker than us. Why? Because as mechanical engineers making beer, I will read the textbook. First, the water. Mechanical engineer does. They know nothing about making beer, and they buy equipment, assemble all of them together, and start making beer. And can you guess the first kind of beer that they make, how does it taste? Tastes like shit. What do they do? What do we do? We have to get water that is 22.2 degrees C. You get what I mean? Okay. So coming back to why do I highlight this? You see this expression, right? What is the solution? How will the system? So this is not done by me. It's done by people a long time ago. I believe they are mechanical engineers. So they had three responses. Okay. So what are the three responses? So the response go like this. Engineers, we draw a graph. Y and time function. So sometimes the graph, the response, this is the response. You don't understand what is the response of the system. It's like when I pinch you, what do you do? Ow, that's a response. Yes or no? You need me to demo? No, right? Okay, here you go. So the first response goes like this. Okay. And then the second response goes like this. And then the third response goes like this. Now, so this, okay, so they saw a response like this. What is the common, so let's go back, so this is writing. What is the common response of this tree graph? Yeah. Mathematically, yes, no time. Oh, what? Oh, damn, you short, right? It's a damn mechanical system. Damn, right? Right. So what's the response of this tree graph? What is the common feature that you see? All converge. So they are all what? Decaying. Right? Right? So they are all decaying. So after they know they decay, right? Right? After they observe their decay, they realize that y over t, or y as a function of time, must have a decaying